will create a linked list with just one node and print the value stored in that node to the screen. So this will help you understand the basic structure of a linked list. So we're going to start off with this header files. So make sure that you have this header files before you begin. And then we're going to start off by defining a structure for a linked list node. So let's begin. So we're going to start off by defining a structure. So we're going to have a struct, and then we can call this structure node. And then inside the structure, we are going to have an integer data. So we're going to say, let's say data, and then we are going to have a pointer that points to the next node. So inside this structure, we're going to have a struct, and then we are going to have a node pointer. So this is a pointer to the next node. So you can call it next, or you can call it whatever you want. Next up, we are going to have this semicolon over there. And then we are going to head over into the main function. So we're going to say int main and curly braces, and then we're going to start off with our code inside the main function. So in this code, we're going to have a new node. So we're going to create a new node. So to create a new node, we are going to say struct. So it's going to be the same name of the structure. So we're going to have node, and then we are going to have a pointer. So the first node, we can call it head, and then we can say this is equal to null. And then what we have to do now is to allocate memory for that one node. So to allocate memory, we're going to say head, and then we're going to say that is equal to, and then bracket, and then we're going to have a struct, and then node pointer. So we're going to have a star right here, and then go outside the bracket and write malloc. So remember, we allocate memory using the malloc function, and then we are going to have a size of. So we're going to have size of, and then inside we're going to have struct. So that should be struct, and then we are going to have the name of the structure, which is node, and then go outside and then put a semicolon. So that is how you allocate memory for one node. So now that we have allocated memory for the node, we have to give that node data. So we have to give it a data. So what we're going to do now is to go to the next line, and we're going to write head. So the first node, which is head, is going to have this. We're going to say this, and then we're going to have data, and then we're going to say that data is equal to, let's say, 20. So that is the value that will be stored in this node. So that is 20. And then we're going to set the pointer to the next node to 0. So we're going to point it to nothing. So we're going to say head, and then we're going to have this, and then we're going to have next, and then we are going to have equal to null. So right now we want to print the data of the nodes. So we want to display the data that is stored inside the node. So to do that, we're going to do printf, and then we are going to say something like data stored in the node. So this is %d, and then what is %d? So %d is head, and then we are going to have this, and then we're going to have data, and then you can put your semicolon over there. And then after that, we have to free the allocated memory. To free the allocated memory, we are going to say freeing, and then we are going to have head. Oh, should be head. And then we are going to have a semicolon and return to, okay, what's happening? Something froze. Okay, then we're going to have a 0 there. And let's run this code and see what happens. So run code. It's compiling. And there we have it. So the data stored in the node is 20. So that is the value that we have put in the node. So now let's do another example. So in this example, we will make the similar example, but with more than one node. So I'm just going to remove this main function. So I need that struct node. So I'm going to keep that one over there. So in this example, we will manually create and link 3 nodes in the list and then print the values that are stored within these nodes. So to do this, we are going to start in the main function. So I'm going to rewrite the main function. So I'm going to have an int main, and then inside the main function, I'm going to create 3 pointers for 3 nodes. So I'm going to start off with struct. I'm going to say struct, and then I'm going to have a node. So this is a pointer to the first node. So the first node, I will call it head, and then this one will be null. And then I'm going to create another pointer. So this is struct, and then I'm going to have node, and then I'm going to have second. So this will be the pointer to the second node. And then when you say this is equal to null also, and then I'm going to have another struct. So struct node star, and then I'm going to say this is the third node, and then I'm going to say this is equal to null. Okay, so okay, it was just freezing there. So now that I have these pointers, now I have to allocate memory for all 3 nodes. So I'm going to say I'm going to start off by allocating memory to the header one. So the head one, so I'm going to say head is equal to, just like before, so we're going to say head is equal to open brackets, and then we're going to say struct, and then we are going to say node, and then we're going to have a star, then go outside, allocate memory, and then you're going to say malloc, and then we're going to have a size of, okay, that should be size of, and then we are going to have struct node inside, struct node. Then we are going to allocate memory for the second node. So we're going to have a second, and then second is equal to struct, inside the brackets we're going to have struct, and then we are going to have node star, go outside, malloc, then inside the brackets we're going to have a size of, and then we are going to have struct node, and then we're going to do the same thing for the third node. So third node is equal to struct, then we're going to have node, go outside, malloc, and then we're going to have a size of struct node. So now that I have allocated memory for the nodes, now I'm going to assign data and link the nodes. So to assign data to the nodes, I'm going to say to the head node, so I'm going to say head, and then head, I'm going to have this, and then I'm going to say data, and then I'm going to say, let's say the first node has the data 10, and then from there I'm going to link the first node to the second node. So to do that, I'm going to say head, and then I'm going to say an arrow, and then I'm gonna say next, and then I'm gonna say this is equal to second, just like that. And then I'm going to assign a data to the second node. So to do that, I'm going to say second, and then I'm gonna have this, and then I'm gonna say data. This is equal to, let's say the second node has the data 20, and then I'm going to link the second node to the third node. So to do this, I'm going to say second, and then I'm going to say next, and then I'm going to say this is equal to third, and then I'm going to assign data to the third node. So I'm going to say third, and then I'm gonna say have that arrow, and then I'm gonna say data. This is equal to, let's say the third node has the number 30, and then I'm going to say the next pointer. So this one will not be linked to anything, so I'm going to set it equal to 0 or nothing. So I'm going to say third, okay, third, then I'm gonna say next, this is equal to now. And now I have assigned data to the nodes, and then I have linked all the nodes. So now I want to print the data that is stored in each node. So to do that, I'm going to have what is known as the temporary pointer. So I'm going to have a pointer that moves from the first node to the last node. So to do this, I'm going to have a struct, and then I'm going to say node star, and then I'm gonna call this temp. So I'm going to say this node, this pointer is currently at the head node, the first node. So I'm gonna say head, and then I'm going to use the while loop, so to loop through the all the nodes. So I'm gonna say while, and then I'm gonna say temp. So inside the temp, as long as temp is not equal to now, so as long as temp is not equal to nothing, I'm going to print the data to the screen. So I'm going to say print f, and then I'm going to say data in node, let's say okay, percentage d. I'm gonna say percentage d right here, and then I'm gonna say \n, just like that. Or let me just put something here, just like this, and then \n. So wait a minute, I forgot to put the things right here. So I'm gonna have this, and then I'm gonna say data in node, and then percentage d. So what is percentage d? So percentage d will be temp, and then I'm gonna have that arrow right there, and then I'm gonna have data. Then I can put my semicolon, and then inside now I can say temp. So now it's like I want to move this temporary pointer to the next node. So I'm gonna say temp is equal to temp arrow next, and then I'm gonna have my semicolon. And now that I have print the data to the screen, I have to free the allocated memory to every node. So I'm gonna say free, and then I'm gonna have a head, then I'm gonna have semicolon, and then I'm gonna have free, and then I'm gonna have second, and then I'm going to have another free, and then I'm going to say third, and then I'm gonna have a return 0. So let's run this code and see what we get. And there we have it. So data in node, we have a 10, we have data in node, and then 20. So this is not right. So maybe, yeah, I should have put a \n right here. So let me do that. So \n. So let me run the code again. Yeah, and there we have it, data in the node. So we have 10, 20, and 30. So this is the first node, and then this is the second node, and then this is the third node. So there is another way of printing the values inside the nodes using a function. So I'm just going to only remove this, and then I'll keep everything as it is so that we don't waste time writing the same thing all over again. So right now I'm just going to create a function before the main function. So I'm going to have a void. So this function will print the values that are stored within the nodes. So we can call it print. So this function is called print, and then we're going to have struct, and then we're gonna have node, and then we're gonna have head over there. And then inside this function, we are going to have a temporary pointer to traverse the list. So we're gonna have struct, and then we're gonna have node, and then we're gonna have a star temp, and then we're gonna say this is equal to the first node, which is head. And then we are going to have an int node number. So we're gonna have a node, let me just say node no, and then we're gonna say this is equal to 1. So the first node is equal to 1, which is head. And then we are going to write the while loop. So a very similar while loop like the one before. So we're going to have a while, and then we're going to say as long as temp is not equal to null. So we're going to have null. And then we are going to print the data stored within that node. So we're going to have a printf, and then we are going to have data. So let me put a capital letter there. So data in node %d. So that will be the node number, and then we're gonna have this, and then we're gonna have the value that is stored within that node. So we're gonna have a \n, and then we have to tell the compiler what is %d. So the first %d will be node no, and then the second %d will be temp arrow, and that will be data. And then we are going to have the semicolon, and then from there we're going to set the node, like the temporary node, to move to the next node. So that will be temp is equal to temp arrow next, and then we are going to increment the node number. So we're going to say node no plus plus, and then from there this is a function, so we have to call this function. So after giving that assigning values to the nodes, we have to call the function to print the values within the nodes. So to call the function, we are going to say let's say we're going to write the function name, which is print. So we're going to say print, and then we are going to have head inside as a parameter. So we're going to say that. So let's see if our code works. So we're going to run this now. Let's see what we're getting. Okay, it's compiling. And there we have it. So data in node 1 is 10, then data in node 2 is 20, the data in node 3 is 30. So now let's take it up a notch by creating a dynamic linked list where we can insert nodes at the beginning and at the end of the list. So we'll also add functionality to transverse and delete nodes and also print to the screen. So this example will demonstrate a more realistic use cases of linked list where operations like adding, deleting, and transversing the list are more common. So we're going to start off by defining a structure. So we're going to have a struct just like before, and then we're going to call the structure node, and then inside this structure we're going to have a data. So we're going to have int data, and then we're going to have a pointer to the next node. So we're going to have struct node star next, and then we are going to have a semicolon over there. So next up, we have to create a function that adds a new node at the beginning of the list. So to do this, we're going to have a void, and then you can call your function whatever you want. I will just call it insert, and then I'm going to have brackets. So inside the brackets, I'm going to have a struct, and then I'm going to have a node, and then I'm going to have a double star. I'll explain in a moment why do we have that, and then I'm going to say head, and then still inside the brackets I'm going to have a comma, and then I'm going to have an int new data. So when we insert a new node at the beginning of the list, that new node has data in it, so that data is called new data, or you can call it whatever you want. So and now we're going to have curly braces. So let me explain what does this mean. So this right here is called a double pointer. So when you pass this, you are giving the function the address of the head pointer, and this allows the function to change the actual head pointer of the list. So in any change, so many changes made to the head in this function will reflect outside the function too. So basically we use this double pointer when you need the function to modify the head of the list, like inserting a new node at the beginning or deleting a node. So since we are going to add a new node at the beginning of the list, so the new node now is going to become the new head. So initially the list had a head node, which is the first node, but now we're adding a new node at the beginning of the list. Now that new node becomes the head of that whole list. So we're going to modify the head of the list to become the new nodes that we have just inserted. So this is why we use this double pointer right here. So next up, we have to allocate memory for the new node. So to allocate memory for the new node, we're gonna have a struct, and then we're gonna have a pointer star, and then we're gonna have new node. Let's call it a new node, and then we're gonna say this is equal to. So now I'm allocating memory to this new node. So I'm gonna say struct, and then I'm gonna have node right there, and then I'm gonna go outside. I'm gonna say malloc. So to allocate memory, malloc, and then I'm gonna say size of. So we're gonna have a size of, and then I'm gonna have struct. So that should be you there, struct node, and case. Oh, I was wondering why I have an error right here. So I have double O right there. That should be fine. Okay, so this line allocates memory for the new node. So next up, we have to assign data to that new node. So to assign data to the new node, I'm going to say new node. So new node, and then I'm going to have that arrow right there, and then I'm going to say data. So I'm going to say that is equal to new data. So next up, we're going to make the next of new node to point to the current node. So to do this, we are going to say new, and then I'm going to say node, and then I'm going to have that arrow right there, and then I'm going to say next, and then this is equal to star head, and then from there I'm going to move head to point to the new node. So I'm going to say head, and then this will be new node. So now the inserted node at the beginning of the list is now the new head, and this is the complete function. So next up, we're going to have a function that inserts a new node at the end of the list. So to do this, we're going to have another function. So we're going to say void, and then this function I can call it insert end. So this is called insert end. You can call it whatever you want. And then inside this, I'm going to have this struct. Then I'm going to have a node double star, and then I'm going to have a head, and then I'm going to have int new data, and then inside the function I'm gonna have to allocate memory for this new node. So we're gonna do the same thing that we done there. So I'm just gonna copy this just like this, copy, and I'm gonna paste it right here. So next up, I'm going to have a line that transverse the list. So the line that transverse the list, so this is struct, and then I'm going to have a node, and then I'm going to have a star last, so it should have a space there, so last, and then I'm going to say this star point. So this is head, not pointer, head, just like that. So this line is used to transverse the list. So next up, I have to assign data to the new node. So to assign data to the new node, I'm going to say new node, and then I'm going to say this, and then I'm going to have that data. So I'm going to say this is equal to new data, and then so now I have to set the pointer of the new node to point to nothing, because we have the new node at the end of the list. So next of that node there's nothing. So I'm going to say the next of this new node is nothing. So the next of this new node is null, just like that. So now let's say if the list is initially empty and we are trying to add a node at the end of the list, but the list is initially empty. So in this case, we're going to have an if function. So if function, we're going to inside the if function, we're going to have a star head, and then we're going to, if the head is nothing, so initially we don't have the head because the list is empty. So if the head is nothing, so that is null, and then we're gonna have this if function. So we're gonna have a star head is equal to new node, just like that, and then we're gonna have a return. Next up, we have to transverse the last node. So to transverse the last node, we're going to use a while loop. So we're going to say the while, and then we're going to say last, and then we're going to have this arrow, and then we're going to say next. So if this is equal to, so that should be equal to, is not equal to, sorry, so that is not equal to now. And then we're going to have something like this inside the while loop. So we're going to have a last, and then this is equal to last, so it should have an arrow, and then I'm going to say next. So next up, I have to link this new node to the last node. So to do this, I'm going to do write this line. So this line last, so last, and then I'm going to say next, and then I'm going to link it to the new node that is being inserted at the end of the list. So this will be new node, just like that. So okay, now let me close the function. So this function, I have to close it up, so this will be calibrated over there. Right, so now it's been closed. Okay, we're not done with functions yet, so now we have to make a new function that deletes a node from the list. So to do this, we're going to have a void, and then we're going to have the name of the function. So I'm just going to call it delete, and then I'm going to have a struct, and then we're going to have a double pointer again. So we're going to have a node star star, and then we're going to have a head, and then from there we're going to have int, and then I can call this variable key, and then inside the function I'm going to have a struct. So I'm going to have a struct, and then node star, I'm going to say temporary node, so temporary temp, and then I'm going to say this is equal to star, it just should be star head. Now I'm going to have a pointer to the previous node to point to nothing, so I'm going to have a struct, and then I'm going to say node star, then I'm going to say, let's call it prev, and then I'm going to set the previous the pointer to the previous node to be nothing. So now I'm going to have an if function. So let's say if the node to be deleted is the head. So to do that, I'm going to have an if. So if temp, so let's say temp is not equal to null, and then we're going to have end temp, so temp arrow data is equal to the variable key. Do this. So if we delete the head, so now I'm going to say the new head. So I'm going to say let's say I'm deleting the head of the list. So the new head now is going to be temp next. So the next node will now be the new head, and then I'm have to free temp, and then I will have to say return, just like that. So now to delete this node, we have to search for it. So we have to search the node with the data key, and then we have to keep track of the previous node. So to do this, we're going to use the while loop. So we're going to have a while, and then inside the while loop, we're going to have a temp. If temp is not equal to 0, so we're going to have is not equal to now, and then we're going to have end temp points to data. Let's say, where's my mouse? So data, and then we're gonna have, so temp data, and then we're gonna have that is not equal to key. So we're gonna have not equal to key. So do this. So we're gonna have a prev, so the previous node now is equal to temp, and then we're gonna have temp being equal to temp next. And now if the node with the key is not found, we have to do something. So we're gonna say if temp is equal to now, so let's say now, then what we have to do, so let's say return, just return. You can print something if you want to, so I just want to return. And now we have to unlink the node from the linked list. So we have to unlink that node from the linked list. So let's do that. So to unlink the node, the deleted node from the linked list, we have to say previously. So the previous node, the previous nodes next, and then we're gonna say this is equal to temp, and then we're gonna say next as well, and gonna have a semicolon, and then we're gonna say free temp, and then we're gonna have a semicolon. So this is the entire function to deleting a node from the list. So we're not done with functions yet, so now we have to do a function that will print the linked list. So to do this, we're going to say void, and then we can call this function print, or you can call it whatever you want. So I'll just say struct inside, and then I will say node star, not a double pointer this now, so we're gonna have a node, and then we're gonna have while, so we're gonna have a while, so we're gonna have to loop into the list. So we're gonna have a while, and then we're gonna say as long as node is not equal to, so that should be not equal to now, and then we're gonna have, so let me do this curly braces over there. Yeah, and then we're gonna print now. So we're gonna say printf, and then we're gonna say %d, and then we're gonna have, let's say, an arrow just like this, and then we're gonna have outside. So outside, let me put a space over there, and then we're gonna say go outside, and then this will be node data. So this will be the node data, and then we're gonna say node, and then we're gonna say node, wait, that should be equal to, so equal to node, and this points to next. So we're gonna print and then increment the node. So we're gonna have like that temporary pointer from moving from node 1, 2, 3, and so forth. So after that, we're going to say outside, so just printf, and I'm gonna have a null here, null, and then \n. And now we have to do the main function now. So now we are done with all the functions. Now we have to do the main function. So inside the main function, we're gonna have an int main, and then curly braces, and now we have to say struct node star, and then we're gonna have the head like this, the pointer to the head, nothing now, and now we're gonna have to insert nodes at the end. So to do this, we're going to say insert, and then, so first of all, let's say, let me check that name for insert. Okay, inserting the node at the end, what did I call it? So insert end. So to insert the nodes at the end, I'm gonna have to say insert end, so that is end, and then I'm gonna say brackets, and then I'm gonna say ampersand, and then I'm gonna have a head. So So now I'm going to add 10, so which is the value inside the node. And then I'm going to insert another one. So I'm going to insert end, and then I'm going to have ampersand head, and then I'm going to have another value, let's say 20 now. And then I'm going to say insert end, and then I'm going to have an ampersand head, and then I'm going to have another value which is 30. And now I have to print the values. So to do this, or let's just print the list, not the values. So I'm going to say printf, and then I'm going to say let's see, list after inserting at the end. And then I'm going to say, so now I'm going to call the function. So to call the function, I'm just going to write its name. So insert end, and then I'm going to have head inside, and then I'll put my semicolon. And now I'll have to insert node at the beginning. So to insert the node at the beginning, I'll have to have the name of the function. So the name of the function is insert. I remember it's just insert, and then I'll have to do this. So I'm going to say ampersand head comma, and then I'm going to add a value, let's say 5, and then I'm going to have a semicolon, and then I'm going to print the list now. So I'm going to say print f, and then I'm going to say the list after inserting at the beginning. Okay, and then I'm going to have my semicolon, and then I'm going to call the function. So okay, let me check something. I think I did something wrong here. So I have to have a print list, not this insert end. Yeah, it should be print, because I want to print the list. So I'm going to have a print. I have to call the function that prints. And then right here as well, I'm going to have a print, and then I'm going to have head, and then semicolon. And now I have to delete the node. So if I want to delete a node, and then I'm going to say delete. So I have to call that function before I call. So I just need the name. Okay, the name is delete. So I have to say delete, and then I'll choose the node that I want to delete. So I'll just say, let's say ampersand head, and then I'm gonna have the value. So the value inside, so let's choose 20. I want to delete this node. I inserted this at the end, and now I want to delete it. So let's say 20, and then semicolon over there, and then from there I want to print the list. So I'm going to say printf the list after deleting a node, and then I'm going to have my semicolon, and then I'm going to say print, and then I'm going to say head. And that's all. So let's just put a return 0. Okay, looks like we have no errors. Yeah, this was a very long code. So let's try and run this code and see what we get. Running, and there we have it. So we have the list after inserting at the end. So we have 10. So initially the list had nothing, so basically we just had 10, 20, 30, and then nothing at the end. And then the list after inserting at the beginning, and then we have 5. You see, now we have 5 before the 10. And then we deleted 20, so the list after deleting a node, we removed that 20. And thanks for watching.